Form 7 Physics, Unit 4, Capacitor Basics. In this video, we are going to focus on capacitor basics, reference textbook 6B chapter, page 44 to 45, and reference in the specification 4.4.100 to 4.4.101. So first point is understand that capacitance is defined as C equal Q over V and be able to use the equation. And the next point, be able to use the equation W equal half QV for the energy stored by the capacitor, and also to derive the equation from the area under the graph of potential difference against charge stored, and be able to derive and use the equations W equal half CV squared and W equal half Q squared over C. What is capacitor? It's a charge storing device. It consists of the two parallel metal plates and insulating material in the middle. And the very important two facts about the capacitor is it has indicated the two values, that is voltage and capacitance. So voltage is mentioned in volts and capacitance most of the time mentioned in microfarads. This is the micro letter, mu is the Greek letter, and with capital F, so we call this unit as microfarad. Now the voltage of the capacitor is very important, as it need to fix to the stated voltage. If you fix a greater voltage or higher voltage than the stated value, there is a risk of damaging the capacitor, or capacitor may get explode. So you have to keen on the fact that capacitor to fix to the appropriate voltage which is mentioned in the capacitor itself. Now let's look at some different capacitors. Now this is a water pump, very familiar to you, and there in the water pump at the top they have fixed a capacitor. This is one capacitor. Now in circuits, a lot of capacitors are there, different types, different shapes. All these are capacitors, right? You can see in a circuit like this, all capacitors fixed. The main function of the capacitor is to store the charge, and whenever it want, it store, and again whenever it's required, it is get discharged to maintain the power supply stable. That is the basic idea and the function of the capacitor. Let's look into the function of it. So this is the two parallel metal plates, plate 1 and plate 2, and when the capacitor is fixed to a power supply, so this is the positive end and the negative end. So electrons are repelled from the negative end, so electrons moves and it's get accumulated on this plate, which become the negative plate, and when the electrons move from this end, electrons are dragged and attract to the positive end from this plate, metal plate. So this plate, when the electrons removed from this plate, so this become positively charged. So this is how the capacitor get charged. How the capacitor get charged? When the electrons flow from one plate to the other plate through the external circuit. For that function to occur, there must be a voltage supply. So it acts as a pump, or it build a pressure on the plates to move from the electrons in one plate to move to the other plate. So how long this happens? Charge will collect on the capacitor until the potential difference, when the charge separates it create electric field. So electric field, there will be a potential difference between the two plates. There is no connection between the two plates. Here the insulating material is there in between, but there will be a field developed between the two plates. So the potential difference develops. How much it develops? Until it equals to the potential difference of the power supply. Now here this animation also you can see. Now the electrons are coming to this plate and become negative, and the electrons remove from this plate and it become positive. That is the how the capacitor gets charged. Then let's have an idea to what is capacitance. Now capacitor is the component, capacitance is the property. Capacitance is the property. Now what is capacitance is the amount of charge capacitor can store. Now as we know that capacitor is a charge storing device, so the amount of charge capacitor can store per voltage applied across its plate is known as capacitance. It's symbolized by the capital letter C. And this idea, amount of charge stored, that is Q, per voltage applied, then that is V, is this ratio is given by the quantity called capacitance. Now very important thing here you to remember, you know that the charge is symbol capital Q, the unit is coulomb, symbol capital C, but here the capital C is used for capacitance. So when you are using this relationship, please keep that in mind, not to twist with quantities and units. Now here very specifically you have to keep in mind charge, symbol capital Q, unit coulomb, symbol capital C, and capacitance here symbol capital C but unit farad, and voltage V, and the unit is voltage. So capacitance unit is farad, symbol capital F, and Q is charge, unit coulomb, symbol capital C, V voltage, symbol V, the unit is volts. And capacitance is depend on the size of the plates and their separation and nature of insulation material between the plates. Let's have an idea of the relationship of capacitance, charge, voltage, these three quantities, relationship between these three quantities. As we define the charge stored per voltage applied, that is C equal Q over V, and Q is CV, then when we object Q it is C into V, and C the capacitance, Q charge in unit coulomb, that's also capital C, and capital C in the relationship is symbolized the capacitance where the unit is farad, and V voltage, unit voltage. So in this equation, this is very a useful equation, and we have to use as much as possible in different situations. So keep in mind not to twist, not to misunderstand, and not to interchange the units and its quantity. So here the Q and C is the problem, because Q the quantity, charge, unit coulomb, symbol capital C, but there is a C in the form relationship also. That C is not coulomb, that is capacitance, and the unit is farad. So keep that in mind very well. Now how capacitor get charged? Let's see it again, as I have just given idea before also how this get charged. So electrons are moving from one plate to the other plate through the external circuit. Very important to say that it is external circuit. Why? Because electrons can't move between the two plates, as in the middle there is a gap which is filled with insulating material. So it may not pass between the two plates one to the other. It's using the external circuit to move, as insulating material in between the plates. So it is very essential to mention that is electrons are moving from one plate to another through external circuit. So what this results? This results store energy in the capacitor. This results energy store in the capacitor. How long this occurs? The charging will occur until the supply voltage here equal to the capacitor voltage. Why the capacitor voltage is building up? Because it create, when the charges separation occur, one plate get positive, one plate get negative, and electric field builds up between the two plates where the potential difference builds. Energy stored in the capacitor. Now here I have plot a graph, voltage against charge stored, that is Q and this is V. And now we know that from the unit 2 electricity, work done on charge. Now work done on charge is equal energy stored in the capacitor. That is the theory here. Work done on charge is become the energy stored in the capacitor. Now what is the work done on charge? Work done on charge is equal charge into voltage. Now charge move through a voltage cause work to be done, because when there is voltage and with the voltage means electric field, a charge is moving through electric field basically. When a charge moves through a electric field, we need to do a work. So that work done on the charge become energy stored in the capacitor. So here at the beginning the voltage is 0. Then when the charge flow, it increases and comes to a maximum value. So that's what here I have put average voltage, because the voltage V is not constant throughout. It's initially 0, then finally it comes to the supply voltage. So maximum value is there and initial value is 0. So let's see to it. Now initial voltage is 0. Then final voltage is the voltage of the supply. This is the final value. 0, final value. And now to get the average voltage, it is 0 plus V supply, voltage supply, divided by 2. So that's how we get the average voltage. Then the work done is W equal Q into average voltage. So average voltage, I substitute 0 plus V supply half. So we get here 0, no value. So V supply divided by 2. So then it become W equal half Q V, or V supply. This is V supply. So that is the final relationship for energy stored in the capacitor. So this is very important to keep in mind. That is, now normally if the in electricity lesson unit we have used and we have learned that energy is charge into voltage. But here for capacitance, keep that in mind. There is a half here. How this half comes? Because the voltage is not V throughout. It is initially 0 and finally come to a max value, or the supply voltage value. So it become average. 0 plus V supply divided by 2 is become V supply divided by 2, as initial value is 0. So here the relationship what we get for the energy stored in the capacitor is half QV. half QV. So now we can see that half QV is the area under voltage charge graph. Voltage charge graph. Voltage against charge graph. So here half is there for the area of the triangle, that's the area under the graph, half Q into Vmax. Vmax is the supply voltage. Yeah, it starts from 0 and it increases up to Vmax. So energy stored in the capacitor, let's come across another relationship. So W is equal half QV. We have derived that in the previous occasion. So as we know that Q equals CV from the relationship for capacitance, capacitance is charge over voltage, and we can get Q equals CV. And if we substitute the Q here from the CV relationship, so what we get half CV into V, so it become CV squared. Become CV squared. Now the two equations are there now for the energy stored in the capacitor. W equal half CV squared, here half QV, here only V, here V squared. Now how to keep this in mind? Okay, you can think and memorize like this. Now if the C is there, you have to see the square here. If the C there, you have to see square here. If C is not present, so no C, so when there is no C, it is Q and only V, right? So if it is necessary only, otherwise you can straight away remember this relationship, and with this relationship you can derive the relationship of this. And on the other hand, now as we use Q equals CV, we can object V, then it become Q over C. So by using the relationship V equal Q over C, we can replace the V there, then it become half Q into Q over C, so it become half Q squared over C. Half Q squared over C. So let's move to a question. Now most mobile phones have touch screens allowing a finger to select different functions. A website explains how this works with a simplified model. The glass screen is coated on both sides with conducting material so that it forms a capacitor. A potential difference PD of 5 volt is applied across the two sides. 5 volt is applied across the two sides. This is conducting material and this is also conducting materials. There is a glass screen in between insulating material, is like as a capacitor now, right? So voltage across it is 5 volts. Question: add to the diagram to show the electric fields between the two sides. Now this is positive. This is the positive end. So this is the negative end. So electrons move, and electrons drag from there. So this become positively charged, and this plate become negatively charged. So what is the electric field? We have learned about the electric field. It is from positive to negative, and it's two parallel plates. So this is uniform electric field, and it has to be marked like this. So you will get the mark there. At least to show a field, we have to show at least 3 lines equispaced by I and arrows from positive to negative. Then next, the arrangement has a capacitance of 12 picofarad, not farad, this is pico, is small. Then how to convert pico to farad is multiplied by 10 to the power minus 12. So calculate the energy stored. So you have to recall the energy relationship. W equal half CV squared, right? Why we use CV squared? Because the quantities given is C and V. That's why. So if not, you can use the Q equals CV and replace replace the Q by the relationship and use it, doesn't matter. But straight away if you use this relationship, it is easy. So then substitute half, then capacitance convert to farad by multiplying 10 to the power minus 12, and volt, as see here, this is, we have to see the square, so it has to be square. There's another place where you can go wrong. Without squaring you may make a mistake. So the final answer 1.5 into 10 to the power minus 10 in joules. Next part, in normal use the capacitor, the capacitor is then disconnected from the power supply, but the charge that gave a PD of 5 volt is left on the capacitor. When the finger touches the screen, the effect is as if a finger capacitor. Now don't worry, now they say that this is finger capacitor, so you need not to think how it is like that, but you have to follow the question of 1.5 picofarad. So it's like this, the arrangement is like this, they are explained like that, connected to the original capacitor, forming the circuit shown below. So the potential difference apply, same potential difference we apply on both, and here the capacitance is 12, here 1.5, both in picofarad, and same potential difference is applied. Some charge flow from the charge, earlier this was charged, and capacitor to the finger capacitor. Now the charge shared between reducing the PD to the same value V. Now earlier there was 5, now it is reduced to V, new voltage, as the charge shared. But we don't know how they share, but one thing we can have, that is the total charge is there. Initially the total charge with this, now both share the charge, so the charge must be equal, initial to the final. So we can use get the total charge before, that is Q equals CV, this is C, and initial V, this is the initial charge. Then later that should be equal to the charge of the both. So here the finally CV, so we don't know V, but we know the capacitance. Capacitance is remaining same, it's not changed, like 1 liter bottle, whether it is full with water or half with water, we call 1 liter bottle. When it half filled, its bottle not become a 500 milliliter bottle, it is still 1 liter bottle, but it is half filled. That is the key thing you have to keep in mind when handling this capacitance idea. So the other capacitor holds that also Q equals CV, C is the 1.5 into 10 to the power minus 12 farad, as it is 1.5 picofarad into V. So we can object V, and V value is 4.4 volt. This is the homework for you. There are 4 questions you can answer and discuss in your sessions, and these are some of the useful links you to go through and have a further idea and enrich your knowledge. So please go through these links and enjoy them, some of the enjoyable, right, and you can gain additional knowledge too. So finally, if we summarize, we have come across this equation for the basic definition, and we have come across the energy stored relationship and derived the another two relationships. Thank you. I hope that you all have enjoyed my video. Let's meet again from another video like this. Till then, goodbye.